Children, we are going to study today the concept of mole. When we go to a supermarket, we always purchase things using standard values. In other words, we always take 1 kg rice or 2 kg sugar or 200 ml of fruit juice, etc. Fruits are sometimes counted by using unit dozen. 1 dozen means 12. These are the terms used in everyday life. But what if I want to measure something in terms of tiny particles present in it? Let me explain in detail. Looking at this block of gold, can you tell me how many atoms are present in it? Looking at this glass of water, can you tell me how many molecules are present in it? You will probably say that it is practically impossible to calculate the number of atoms or molecules in these examples. But astonishingly, chemistry has an answer to this well. That brings to the concept of mole. What does it mean? It is very easy. 1 mole of anything has 6.022 times 10 raised to 23 atoms or molecules or particles present inside it. Isn't this number huge? How big the number is looking like. 1 mole of anything contains these many particles or atoms or molecules. Let us take a substance which contains 3 times this number of particles. Then we will say 3 moles of this substance. If I have a substance which has 8 times this number of particles, then I will say 8 moles of that substance. This is the basic concept of mole for any substance. 1 mole is equal to 6.022 multiplied by 10 raised to 23 atoms or molecules or particles. Therefore, 3 moles will be equal to 3 multiplied by 6.022 into 10 raised to 23 particles. 8 moles is equal to 8 multiplied by 6.022 into 10 raised to 23 particles. Is it clear to you? 1 mole of pure gold contains 6.022 multiplied by 10 raised to 23 gold atoms. 1 mole of pure water contains 6.022 multiplied by 10 raised to 23 molecules. So, if we take a bag which contains 6.022 10 raised to 23 hydrogen atom, then can we say that it is a 1 mole of hydrogen? Yes, you are right. It is 1 mole of hydrogen because it contains 6.022 into 10 raised to 23 hydrogen atoms. Similarly, 6.022 times 10 raised to 23 molecule of copper sulfate is 1 mole of copper sulfate. Isn't it simple to understand? Let us see the scientific definition of 1 mole. Amount of substance that contains the same number of atoms or molecules or particles as there are atoms in 12 grams of carbon 12. Let us break this definition into two subparts. Number of particles in 1 mole and number of atoms present in 1 mole of carbon 12. So whatever number of particles present in 1 mole is always equal to number of atoms which are present in 1 mole of carbon 12. So atoms in 1 mole of gold will be equal to atoms in 12 grams of carbon 12. Carbon 12 is taken as a reference atom. So in 1 mole of gold, how many atoms of gold are present? 6.022 into 10 raised to 23 atoms of gold. And 6.022 into 10 raised to 23 atoms of carbon 12 are present in 1 mole of carbon. Similarly, molecules in 1 mole of water will be equal to atoms present in 12 grams of carbon 12. One mole of carbon 12 is equal to 12 grams of carbon 12. It contains Avogadro's number of atoms. Carbon 12 is used as a standard reference atom. This is used to compare number of atoms, molecules, particles present in the substance. 6.022 multiplied by 10 raised to 23 is called the Avogadro's number. It is just a number to represent the quantity, as we use the word pair for 2, dozen to represent 12. Similarly, Avogadro's number is the term used to represent 6.022 multiplied by 10 raised to 23 number of any entity. So, can we say that if I want Avogadro's number of chocolates? Of course we can, but the only problem is that the shopkeeper will not have as many chocolates and you will not be able to carry them at home. So Avogadro's number is the number represents quantity. The number is so huge, so using it in daily life is practically impossible and not advisable. Then why does this number exist? If we do not use it, it is not used in daily life, but it comes to rescue the work of chemist who deals with atoms, molecules, elements and many substances and huge number of particles. So for this reason it is used to calculate 1 mole of substance. Let me ask you one question. If you answer it carefully, then it will be clear that you have understood the concept of mole. What will be the mass of 1 mole of pure gold? Will it be 12 grams? 1 mole of pure gold is equal to number of atoms present in 12 grams of carbon 12. It is right. But what is the mass of 1 mole of pure gold? Will it be equal to 12 grams? No. It will not be equal to mass of carbon 12. 1 mole of pure gold, its mass will be different from 1 mole of carbon 12. Mass of pure gold is equal to 196.97 gram and mass of carbon is 12 gram. So mass of gold atom is different from mass of atom of carbon 12. Gold atom is different from the atom of carbon because their mass is different. 1 mole of pure water contains Avogadro's number of molecule, but it did not weigh 12 grams. So if we take 1 mole of water and find its mass, we will get answer as 18 grams of water. How it has been calculated? You already did the activity of molecular mass. How to calculate molecular mass? Uh, Water has molecular mass 18 gram. Now let us take an example. of three different elements: gold, silver and copper. 1 mole of each element is taken and all of them will have the same number of atoms in them. 6.022 multiplied by 10 raised to 23 atoms. So this number is called as Avogadro's number. But mass of each of them will be different because mass of each atom which make these elements will be different. Mass of gold will be different from silver and mass of silver will be different from copper. Elements are different, so mass of each element will be different. This slide will help you to understand the concept well. Three different types of dal are shown on this slide: tur dal, masur dal and chana dal. Weigh each grain of each dal. Will it be same? Weight of single grain of each dal, will it be same? No, it will not be the same. Mass of each grain will be different. Now, if we take constant weight of each grain, that is suppose 10 gram. 10 gram of each dal is taken and now count the number of dal grains. Will it be same? No, it will vary because the size of each grain varies. So here each dal grain is analogous to an atom of an element. Each dal grain is similar to an atom of an element. Thus, different dal grains represent atoms of different elements. If equal number of atoms of different elements are considered, then their weight will be different. And if equal weight of different element is considered, then number of atoms will be different. So this problem was solved by chemists. While carrying out a chemical reaction, it is convenient to measure out quantities that can be handled instead of counting the numbers of atoms and molecules. The concept of mole is useful for this purpose.